Function of the tubules. Here you can see the structure of nephron with the different parts of the tubule, namely proximal convoluted tubule, Henle's loop, distal convoluted tubule and collecting duct. Let us learn one by one. First is about proximal convoluted tubule. Here you can see the extended view of proximal convoluted tubule, which reabsorb about 80% of electrolytes and water. And this proximal convoluted tubule or PCT also helps to maintain the pH and ionic balance of the body fluids by selective secretion of hydrogen and potassium ions. So, PCT is lined by simple cuboidal brush border epithelium, which increases the surface area for reabsorption. Nearly all of the essential nutrients and 70 to 80% of electrolytes and water are reabsorbed by this segment. Now, PCT also helps to maintain the pH and ionic balance of the body fluids by selective secretion of hydrogen ions, ammonia and potassium ions into the filtrate and by the absorption of bicarbonate ion from it. Second part is Henle's loop. Here you can see the Henle's loop with descending and ascending limb, or it is otherwise called loop of Henle. This region plays a significant role in the maintenance of high osmolarity of medullary interstitial fluid. And the descending limb of loop of Henle is permeable to water but almost impermeable to electrolytes. This concentrates the filtrate as it moves down. Here you can see the descending limb of loop of Henle where water is shown with arrow towards outside. That means it is permeable to water, this limb. So when the filtrate moves through this limb, the filtrate becomes concentrated. Whereas the ascending limb is permeable to electrolytes. So when the filtrate moves through the ascending limb, the filtrate becomes diluted. So the ascending limb of loop of Henle is impermeable to water but allows transport of electrolytes actively or passively. Now therefore, as the concentrated filtrate passes upward, it gets diluted due to the passage of electrolytes to the medullary fluid. Now about the distal convoluted tubule or DCT. Here you can see the elongated view of DCT, which is also capable of reabsorption of bicarbonate and selective secretion of hydrogen and potassium ion. So, conditional reabsorption of sodium ion and water take place in this segment. DCT is also capable of reabsorption of bicarbonate ion. So, this DCT or distal convoluted tubule also helps to maintain the pH and sodium potassium balance in blood. So, DCT is also involved in selective secretion of hydrogen and potassium ions and to maintain the pH and sodium potassium balance in blood. Next is about the collecting duct. This long duct extends from the cortex of the kidney to the inner parts of the medulla. Large amounts of water could be reabsorbed from this region to produce a concentrated urine. Here you can see the structure of collecting duct, and there it was shown the passage of small amount of urea into the medullary interstitium. So this segment allows passage of small amount of urea into the medullary interstitium to keep up the osmolarity. So this collecting duct also plays a role in the maintenance of pH and ionic balance of the body. So this is done by the selective secretion of hydrogen ion and potassium ion. Hence, it plays a role in the maintenance of pH and ionic balance of the blood. Hope you understood the function of the tubules well.